Metric integral. I'm your host, Dr. D. Okay, time to get started. Trig integrals. Now, these things are going to be some major rock and roll. Okay, so get ready. Okay, now, cosine cubed x dx. What are we going to do with that? Well, I notice that cosine cubed x equals cosine squared x times cosine x. So, let's just make that substitution. Next thing I notice is cosine squared is 1 minus sine squared. Because we know that sine squared x plus cosine squared x equals 1. So I can change my cosine squared x into 1 minus sine squared x. Okay, now I'm ready for a u substitution. Because notice, if I let u equal sine x, then du cosine x dx. Bam! Okay, so let u equal sine x. So du is cosine x dx, which is parked right in front here. So all we have to do is toss in that u substitution, and we have 1 minus u squared du. Now I'm ready for the integral. So I just go, the integral of 1 minus u squared is going to be u minus u cubed over 3 plus c, senor. So now I just plug in my u's, or my sine x back for u. So I end up with sine x minus sine cubed x over 3 plus c. That's it, game over. Okay. Notice, though, what I found when I had an odd power on cosine is I could squirrel away a cosine x dx, change what's left of cosine into sine, and now I have my u substitution, and bam, there we are. Okay, cruising onward. Now notice I have a similar situation here. I have an odd degree, or an odd exponent on sine. So what I'm going to do is I'm going to squirrel away that sine x dx, and I'm going to have another u substitution waiting for me. So this equals the integral of sine to the 4th x times cosine squared x. Oops, rats, blew a tire. I forgot the whole point of that was to squirrel away my sine x dx. All right, now, notice I've got sine x dx. That means that's basically going to be, if I let u equal cosine x, then du is going to be sine x dx, negative sine x dx. So that's exactly what I'm going to do. Let u equal cosine x. So du equals negative sine x dx. Okay. Now remember, I don't want negative sine x dx, I want sine x dx. So that means sine x dx equals negative du. Okay, so I'm now ready for my u substitution. Oh, not quite. Okay, if I'm going to let u equal cosine x, then I need this sine to the fourth to be in terms of cosine x. So that means I'm going to say that sine to the fourth x equals sine squared x squared, which equals 1 minus cosine squared x squared. Because remember, sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. So now I rewrite this as integral of 1 minus cosine squared squared times cosine squared times sine x dx. Now my sine x dx becomes a negative du, and all my cosines just become u's. So I have negative integral of 1 minus u squared squared times u squared du. Okay, so this equals the negative integral of 1 minus 2 u squared plus u to the fourth, all times u squared. All I did was expand my a minus b quantity squared is a squared minus 2ab plus b squared. Good thing you had a good Algebra 2 teacher. And now all I do is distribute my u squared. So u squared times 1, u squared times 2u squared, u squared times u to the fourth. Now, piece of cake. So when I integrate this, it equals, now let's go up here. It equals the negative u cubed over 3 minus 2u to the fifth over 5 plus u to the seventh over 7 plus c. Now we don't care if the c is plus or minus because it's just a random constant anyway. So now we're going to distribute our minus here. So we have, let's do two steps at once. Distribute our minus and put the cosine x back in. So I've got negative 1/3 cosine cubed x plus 2/5 cosine to the fifth x minus 1/7 cosine to the seventh x plus c, senor. That's it, game over. Let's see. Yeah, the book agrees with me. Okay, that's always handy. Okay, so that's it. So you notice I saw an odd exponent for sine, and so I squirrel away one of those signs, and then I make u cosine, so du becomes my negative sine dx. And then the rest, it's like falling off a log. Okay, cruising onward. The integral from 0 to pi of sine squared x dx. Ooh, this is just delicious. Gives you just a little tingle thinking about it. All right, now first of all, we have limits of integration. This is a definite integral now. But secondly, we've always had an odd exponent for sine or cosine. So we've been able to take one of the sine or cosines off and squirrel it away. Well, we can't do that this time. So what we need to do is figure out another way of showing what sine squared x is. If you remember back to your trigonometry class, and I know you all had an excellent trigonometry teacher, you know that sine of theta over 2 equals the square root of 1 minus cosine theta, all divided by 2. You remember that. So what we're going to do is we're going to say let x equal theta over 2. Now if x is theta over 2, then what's theta going to be? It's going to be 2x. Okay, so now I'm going to plug this in. So I have sine of theta over 2, which becomes sine of x, equals the square root of 1 minus cosine theta. Well, that's cosine 2x. All over 2. Now, I square both sides. So I get sine squared x equals this thing, 1 minus cosine 2x, all divided by 2. Or another way I could write it is sine squared x equals 1/2 times the quantity 1 minus cosine 2x. Bam! So, now, I'm going to go through this one more time with cosine. So we'll just squirrel this puppy away because we'll want that for our integral right there. But the same thing can be done with cosine theta over 2. Because we know that equals the square root of 1 plus cosine theta, all divided by 2. Now if we let x equal theta over 2, then what we have is cosine of x equals square root of 1 plus cosine theta is 2x, all over 2. Square both sides, and I have cosine squared x equal, get rid of the radical here, and what do we have? 1/2 times the quantity 1 plus cosine 2x. So, by remembering a simple trig identity, we've got trig identities that are going to help us to do this kind of integration. Now, if this was the integral of cosine squared x dx, I would use this one. It's the integral of sine squared x, so I'm using the top one. So, this becomes the integral from 0 to pi of 1/2 times 1 minus cosine 2x dx. Okay, so now this becomes the integral from 0 to pi of 1/2 minus 1/2 cosine 2x dx. Now, yeah, let's go through it formally first. There's a shortcut with this, but we'll just go through formally. What we're going to do is say, let u equal 2x. And that means du equals 2 dx. And now that means dx equals 1/2 du. Okay, dx is 1/2 du. All right, so now if u equals 2x, I have limits of integration from 0 to pi. So I'm going to make this the limits of, if I'm going from x equals 0, then that's the same as going from u equals 0. And if I'm going from x or up to x equals pi, well, if x is pi, then u is 2 pi. Okay, so now my new integral with the u's in it becomes the integral from 0 to 2 pi of 1/2 minus 1/2. Now, cosine 2x becomes cosine u, and the dx becomes 1/2 du. Okay, so what I have is the integral from 0 to 2 pi of 1/2 becomes just 1/2 u. Now, minus 1/2 times 1/2 is 1/4, and integral of cosine u is sine u. And I'm going from 0 to 2 pi. Now sine of 0 is 0, so the bottom limit of integration is just 0. So basically I just put in my 2 pi, so 1/2 of 2 pi is pi minus 1/4, well notice sine of 2 pi is 0. Bam, that's it. The integral equals pi. Let's make sure. Something has gone awry. Let's try something different. Okay, so notice we have this right here. I'm going to do this integral from 0 to pi of 1/2 first. So the integral from 0 to pi of 1/2 is going to be 1/2 x from 0 to pi. So I basically performed that integral already. Now I'm going to go minus the integral, and we'll do our u substitution here. So it's going to be 1/2. Oh wait, I forgot the limits of integration. From 0 to 2 pi, and I've got 1/2 times cosine u dx, which is 1/2 du. Okay, so this is going to be 1/2 pi minus 1/2 times 0, which is going to be pi over 2, minus, now 1/2 times 1/2 is 1/4, times the integral of cosine u du, which is going to be sine u from 0 to 2 pi. Okay, now notice sine of 2 pi is 0 and sine of 0 is 0, so this whole thing just becomes pi over 2. Okay, so notice I didn't want to do the u substitution on both integrals, only on the second integral, so I end up with pi over 2 minus 0. That's it. Game over. Now, the thing I wanted to show you here is when I integrate cosine 2x, I end up with sine 2x, but then notice I have the reverse chain rule. So it becomes sine 2x times 1/2. So 1/2 times 1/2 is 1/4 sine 2x. So that's it. All right, now let's summarize. Oh no, we have one more. Okay, so the integral of sine to the 4th x dx. Now we have the same situation. We don't have an odd sign, so we can't just take a sine out and scroll it away, or else we're going to have a sine cubed, and you can't take a sine cubed and make it into 1 minus cosine anything. So we need to deal with this just like before. So we say this equals the integral of sine squared x squared. Okay, now, sine squared x equals 1/2 times 1 minus cosine 2x, oops, squared. Notice all I did was I made my sine squared x 1/2 times equality 1 minus cosine 2x, which was the identity we just learned. And since it's squared here, it's squared here. Okay, now, all I do is distribute the square. So I have integral of 1/2 squared, which is 1/4, times, now, this becomes a minus b quantity squared, so it's a squared minus 2ab plus b squared okay, now I've got, well, yeah, now what we want to do is we want to let yeah, you know what, let's just do this integration. We'll do what we can right now instead of complicating things. So we've got the integral of 1/4 minus 1/2 cosine 2x plus 1/4 cosine squared 2x dx. So the integral of 1/4 is 1/4 x. The integral of minus 1/2 cosine 2x. Now let's do the reverse chain rule. See, if I was going to take the derivative of cosine 2x, then that would be negative sine 2x times the derivative of the inside of that function, which is 2. So now the integral of cosine 2x is going to equal, the integral of cosine u would be sine u. But then I'm going to have the 2, basically u equals 2x, so du equals 2 dx, and dx then would equal 1/2 du. So there's my 1/2. So 1/2 sine 2x. Now notice, if I took the derivative of this, it would be 1/2 cosine 2x times 2. Well, so the 2 and the 1/2 would cancel, and I'd be left with cosine 2x. So that's all we're doing right here. So we have minus 1/2 times 1/2 sine 2x. So that's 1/4 sine 2x. Now, plus 1/4 times the integral of cosine squared 2x, rats, just blew a tire, 2x dx. All right, now, notice we went from sine to the 4th to just cosine squared. So now what we're going to do is use our identity one more time. So this equals 1/4 x. Well, you know what? Here's what we'll do. Just to simplify this. We're going to go the integral of cosine squared x dx equals the integral of 1/2 times the quantity 1 plus cosine 2x dx, which equals the integral of 1/2 plus 1/2 cosine 2x dx, which equals the integral of 1/2 becomes 1/2 x. Now, the integral of cosine is sine. We just did that exact thing right here. So we've got plus 1/2 sine 2x times 1/2, which is going to be 1/4 sine 2x. Plus c, senor. Well, we'll put our plus c when we get finished with the whole thing. So notice what we have now is this integral becomes 1/4 times all this. So we've got 1/4 x minus 1/4 sine squared 2x plus 1/4 times 1/2 x plus 1/4 sine 2x plus c, of course. So now what do we have? 1/4 x plus 1/8 x, that's going to be 3/8 x, minus 1/4 sine squared 2x plus 1/16 sine 2x plus c. That's it, game over. Now let's see. Hopefully we can screw that up. Let's see. 3/8 x minus 1/4 sine 2x plus Nah, something has gone awry. What the heck did we screw up this time? We have 3/8 x. How do we get sine squared 2x? It's not sine squared 2x, I just put that in. Yeah, I just manufactured a square for some reason. So let's go back and make sure. Okay, the integral of cosine 2x is sine 2x times a half. And then we've got plus 1/4 cosine squared 2x. Oh no. Ugh. Let's go back. This is okay. Now we're back up to here, and we've got the integral of cosine squared x. But I didn't want cosine squared x, I want cosine squared 2x. Sometimes I wonder when I make a screw up like that, and you're watching the video, if you're like catching on that I screwed up and that all this is completely wrong, or if you're following right along with my screw up. Okay, we've got the integral of cosine squared 2x. So this equals the integral of 1/2 times the quantity 1 plus cosine 2 times 2x. Okay, so there's our half angle identity. Now this becomes the integral of 1/2 plus 1/2 cosine 4x dx. Now, integral of 1/2 is 1/2 x. The integral of cosine 4x would be sine 4x times 1/4. So 1/4 times a half is 1/8. And then plus c. So now we put that back in here. So it's 1/4 times all that I just integrated. So 1/2 x plus 1/8 cosine 4x. And we'll put our plus c at the very end here. Now, let's add up what we have. We've got 1/4 x plus 1/8 x is 3/8 x. Now we've got minus 1/4 sine 2x, which is right. Now we've got plus 1/32 cosine 4x plus c. So, yeah, that's it. That is correct. Okay, that's enough. All right, so you see how grisly this can get. Like all it takes is one little slip up and you're completely messed up. All right, so let's recap the action. If I have the integral of sine mx times cosine nx dx. If m is odd, that means I have an extra sign floating around, so I can have a sine x dx. Well, if I want du to be sine x dx, then I make u cosine x. So then, if u is cosine x, I make everything in terms of cosine x, which means all the sine squared x's become 1 minus cosine squared. And then I can do my u substitution because u is all the cosine x's, and everything is happy. Now, if n is odd, which means the exponent of cosine being odd, well, then I'm going to squirrel away a cosine x dx, which means u will be sine x, so du is cosine x dx. Make everything in terms of sine x. That means cosine squared will be 1 minus sine squared, and u will be all the sines. Now, what if we don't have either sine or cosine odd? Sine and cosine are both even. Well, now we need our sine squared equals 1/2 times 1 minus cosine 2x, and cosine squared equals 1/2 times 1 plus cosine 2x. That's it. Have fun with these. Well, have fun with these. We're about to go into part 2 of this exciting section.